Hello, in this video we're going to be looking at factorising quadratics that are specifically Monic quadratics. So the objective here is to factorise quadratics of the form x squared plus bx plus c. But firstly we need to ask ourselves, what is a Monic quadratic? So a quadratic is any expression where the highest power term is an x squared term. Specifically, the quadratic is monic if the coefficient of x squared is a 1. So if we have, for example, x squared plus 7x plus 10, x squared minus 36, x squared minus 5x minus 24, and x squared plus x minus 30. So these are all examples of monic quadratics because the highest power term is an x squared term, and the coefficient of x squared in each of these cases is a 1. Okay, so if we had something like 2x squared plus 5x minus 7, this is non-monic because the coefficient of x squared is a 2. And also if we have something like x to the power of 4 minus 7, this thing is not a quadratic because the highest power term isn't a squared term. So we need to be able to factorise monic quadratics. So the method is below. So we need to think of two numbers that multiply to the c term and add to the b term. Once we've got our two numbers, we write it in the form x plus m, x plus n, where m and n are the two numbers that we've just found. Okay, so that might sound a bit confusing and a bit weird. So we're going to go through a few examples to show that it's actually not as weird as it looks. So here's an example. We have x squared plus 7x plus 10. So we need to factorise this, so we need to put it into brackets. So the first thing we need to do is think of two numbers that multiply to this number on the end and add to this number in the middle. So we need two numbers that multiply, in this case, to 10 and add to 7. So if we think of the factors of 10, so I know that 1 and 10 multiply to make 10, but 1 plus 10 would be 11. So it's not 1 and 10. Alternatively, I could have 2 and 5. So I know that 2 times 5 is 10, and I also know that 2 plus 5 is 7. So that tells us that we have the right combination of numbers. So once we have the combination of numbers, we simply write it as x plus 2 and x plus 5. So the 2 and the 5 are the numbers we have just found. So once we've done that, we have our answer. If we wanted to double check that our answer is correct, we could by all means expand out the bracket. So x plus 2 times x plus 5 using our FOIL method. So x times x is x squared, x times 5 is 5x, 2 times x is 2x, and 2 times 5 is 10. So if we simplify that, we have x squared plus 7x plus 10, and that is the expression that we're trying to factorise in the first place, and so we know we've done it right. Okay? So this question here, so we need to think of two numbers that multiply to this number on the end and add to this number in the middle. So the two numbers need to multiply to 14 and add to make minus 9. So if we go through the factors of 14, so we have 1 and 14, we have 2 and 7. Now, there's nothing that I can do to 1 and 14 to get to minus 9. But if I take 2 and 7, we need to get to minus 9. So if I made this a minus 2 and this a minus 7, I would have minus 2 minus 7, which is minus 9. But I'd have to do the same to the top one. So minus 2 times minus 7 is also 14, because two negatives make a positive. So I'm going to have x minus 2 and x minus 7, and that is the answer. Okay? So this one here, so we need to think of two numbers. This time they need to multiply to make minus 35, and they need to add to make 2. So numbers that multiply to make 35, we have 1 and 35, we have 7 and 5. So I'm going to go with the 7 and 5 example because I know there's nothing I can really do to 1 and 35 to get 2. So if I go with 7 and 5, we need to play around with this until these calculations are correct. So 7 plus 5 is 12, but if instead I made the 5 a minus 5, I would have 7 minus 5, which is 2, which is great. but I'd have to do the same thing to the top one, so make that a minus 5. So 7 times minus 5 is minus 35, so I know I've got the right combination. So the answer to this is going to be x plus 7 and x minus 5. Okay? So this question here, we need to think of two numbers that multiply to the number on the end, which is minus 30. But this time, what do they need to add to? So this time we have plus x. So they need to add to the coefficient of the x term. I mean, it's not obvious because it's not written down, but when we have x by itself, that x by itself is an imaginary 1. So this time they need to multiply to minus 30 and they need to add to 1. So again, I'm going to think about the factors of 30. So I've got quite a few here. So I've got 1 and 30, I've got 2 and 15, and I've got 6 and 5. So of these three possible pairs, I need to think of one that we can do something to get to a 1. So 1 and 30, there's not really anything you can do to 1 and 30 to make a 1, so we can exclude that one. 2 and 15, again, if we add them, we get 17. If we minus them, we get minus 13. So again, that one isn't really going to work. So 6 and 5, so there are some options for this. So we need to get to 1. So I know that if I made the 5 a minus 5, we would have 6 take away 5, which is 1. So if I make it a 6 and a minus 5, and then just check that the multiplication makes sense, so 6 times minus 5, I know is minus 30, so that means we've got the right pair. So it's going to be x plus 6 and x minus 5, okay? So this example here, again, there is no coefficient of, there is a coefficient of x, but it's kind of hidden. So I'm going to write in a minus 1 because when it's minus x, that's an imaginary minus 1x. So the two numbers in this case need to multiply to make minus 12, and they need to add to make minus 1. So again, there's a few options here if we think of the numbers that multiply to make 12. So we have 1 and 12, we have 2 and 6, we have 3 and 4, and that's about it. So of these three options, can we do anything to any of them to get minus 1? Now we can, because we've got a 3 and a 4. So if I made the 4 a negative 4, I would have 3 take away 4, which is minus 1. So it's 3 and minus 4. But I just need to check that 3 times minus 4 is minus 12. And yes, it is. So that means we've got the right pair. So that means that the answer is x plus 3 times x minus 4. And that is correct. So here's an exam style question on this topic. So for 2 marks, we need to factorise this fully. So for this one, we need to think of two numbers that multiply to make minus 16 and add to make minus 6. So we're going to do the factors of 16. So the factors of 16 are 1 and 16. We have 2 and 8, and we have 4 and 4 as well. So of these three options, can we do anything to any of them to get minus 6? Well, 1 and 16, 1 plus 16 is 17, and 1 take away 16 is minus 15, so that one's not an option. 2 and 8, 2 plus 8 is 10, but if we did 2 take away 8, we would get minus 6. So that means 2 and 8 would work, so 2 minus 8 is minus 6. But if we do 2 times minus 8, that happens to be minus 16, so that's good, so we can have that. So the answer to this question is x plus 2 and x minus 8. So here's a couple of examples, so quick fire practice questions. So if you want to pause the video here so you can have a go at these questions, I'll show the answers in a moment. Okay, so welcome back if you had a go at those. The answers have just been displayed on the screen, so if you want to mark the questions you've done. If you have any issues with these questions, I would encourage you to maybe go back and check to see where you've gone wrong. But that is everything for factorising Monic quadratics, so I'll see you next time in another video. Bye!